Hello, today we are going to briefly talk about the first part of the 8.2 packet. We are going to skip to more day 2 stuff, talking about vertical and horizontal asymptotes. We've used asymptotes before. Let's review what they are. Asymptotes are those lines that the graph never crosses or is never equal to. Here we have two purple asymptotes. We have this one that goes up and down, but notice it passes through one number the whole time, and that's the 2x. So this is a vertical line, and so this vertical asymptote is x equals 2. Then we have this horizontal asymptote, and you notice that there's one number it hits the whole time. We're going to jump backwards for a second to day 1. This is the second page of the 8.2 packet, day 1, and look at these asymptotes again. We have a vertical asymptote, that's where x equals, of 2. So I'm going to put the x equals 2 right here because it crosses through 2 the whole time. We have a horizontal asymptote of 1. Notice both graphs only cross through, or actually never cross, the 1 line. The 8.2 notes look like this. They are boxed and tabled. We are going to go down to the third box. In this third box, we have a graph that goes this way and a graph that goes this way. Now, one thing I've heard Mr. Whitehill say in past years, and he does a little dance you could probably imagine with it, is he calls VA VA. And so he'll ask, what's the VA of the graph? And our VA here is our x. And it looks like if this is -5, that this line crosses -5, and this line gets really close to -5. So I'm going to guess that the VA is -4 here. And then you can imagine Mr. Whitehill asking, what's the HA? Where does the graph HA? Well, this is the horizontal asymptote, and it has, right here it goes past 0, and right here it never quite hit 0. So in between, just past 0 and almost to 0, we're going to guess that that HA is 1. So again, this has a VA of -4 and a HA of 1. Sorry, this box is kind of blurry, but here we're going to talk about vertical asymptotes with numbers this time instead of graphs, like the video from day 1 where the woman that was talking about the bottom. So the first thing I'm going to look at is, do any of the top and bottoms cancel? And I see an x plus 5 on the top. That matches the one on the bottom. So just like in other fractions, they cancel. And we're left with an x plus 7 on the top, x minus 9 on the bottom. Now remember from our notes, the vertical asymptotes were only concerned about the bottom. I rewrite the equation with my cancellations. We're only concerned about the bottom, so we're going to solve the bottom. X minus 9 equals 0. When we move the 9 over, subtraction becomes addition because we do the opposite, and we're left with x equals 9. So our vertical asymptote for this equation is x equals 9. In this equation, we see that -3 x minus 3, in parentheses, and x minus 3 in parentheses on the bottom cancel each other out. This time when they cancel, we're only left with a top of x plus 4, but a bottom of 1. So we're going to rewrite that here. And remember, with vertical asymptotes, we set the bottom number equal to 0. So this time we have an equation that says 1 equals 0. But that's not true and can never be true. 1 cannot equal 0. So our answer is 1 cannot equal 0, or we just say no VA or no VA, no vertical asymptote, because 1 can never equal 0. We are going to move to the bottom right-hand corner of this page to do one last thing. So this time we need to take the bottom and factor it before we can reduce, because there's a chance that down here we have an x minus 6. So I'm going to make my x chart, and so what multiplies to make negative 30, but adds to make, is that negative? Negative 1. So what are numbers that multiply to make negative 30 but add to make negative 1? Well, if 1's negative, that means the bigger number has to be negative. So if we do 3 and negative 10, that makes negative 30, but negative 7's too big, so it can't be that. How about numbers that are closer together? 5 and 6. Which one has to be negative? Well, we just said that if the bottom number here, the add number, is negative, then the bigger number has to be negative. So this time with 5 and 6, it's going to be negative 6. Negative 6 plus 5 is negative 1. So up here we're going to put x minus 6 and x plus 5. And that's good for us, because if we remember, we have an x minus 6 on the top. So our x minus 6's cancel again. And we're left with a 1 on top and an x plus 5 on the bottom. Remember, we're solving for vertical asymptotes. So it's the x plus 5, which is on the bottom, that we set up equal to 0. So to move the positive 5 to the other side, we do the opposite. So we subtract 5 from both sides. And we're left with a vertical asymptote of x equals negative 5. I'll put my little equal sign in there. So on a graph, this vertical asymptote, remember, goes up and down. So if this is negative 5, our vertical asymptote is going to come all the way down through negative 5, and the graph will never cross or meet on either side of the negative 5. Now it's your turn to practice on the assignment. Have a good day.